Good morning, Professor.
Hey, good morning, Angelica. How's the rest of the class? Huh? How's everybody else? I heard only Angelica only, and there are still like six more people in this class, in this session, and nobody else has graded back, huh? I wonder what's going on with everybody else. Um, let's see. So I have 7 people there, and then let me check how many people are here. There are 8 people in the discussion board. So yeah, numbers are matching. All 8 people in both today's forum and collaborate. All right. So let's see. So, oh yeah. In the last class, we have. Okay, let me open the whiteboard. Okay. So, in our last class, right, we were talking about. Basically, we completed our discussion and exercise on compounding and discounting, right? Remember, yeah, I'm gonna do this. Okay, there you go. So, compounding is the process to find the future value, right? When that means, principal, we know principal and interest rate and time. Yeah. And then discounting is the reverse process of compounding. It's a process to find the present value, which is actually the principal, right? And it is the reverse process of compounding, right? Okay. Basically, we can solve for any variable since we are, think about it. The equation is comprised of 4 variables, right? Future value, principal, which is basically present value, right? And R, right, the interest rate, and T, time, right? Of course, the generalized, I should use, the generalized notation of N. I better call this N. I think I better call this N because N is more generalized symbol than T, because T is time, and usually, T would represent, T is represented in years. I mean, T is expressed in years, or months, or weeks, or days, but in compounding, it is usually in years. Therefore, and considering the compounding frequency, right? Considering the compounding frequency, what matters, what goes into compounding is actually the actual number of compounding, right? Okay, that's n, right? It's hard to so we have that's why we have 4 variables once again from the initial formula, right? Initial equation. Everything starts from the initial equation, right? So each of these variables can be the unknown, right? So, oops. If future value is the unknown, that means the rest of them are known. Then solving for future value, right? Because future value is the unknown, you will solve for it with the rest of the other variables known, right? Or given. And if principal is the unknown, if the principal is the unknown, you solve for the principal this way. In other words, I've been telling you, the key to solving any equation, right? The key to solving any equation is to identify z equals x times y structure, right? You need to identify z equals x times y structure. Right? And if you can identify the structure, you can solve for anything, right? The point is, if you can identify z equals x times y structure, right? Z equals x times y structure already tells, z is the unknown, and that's what we're solving for. But if x is the unknown, we can solve for x by dividing z by y. If y is the unknown, we can solve for y, right? By dividing z by x. So so far we have addressed these 2 unknowns, right? What if, then the next question is, what if, right? Or the rate is the unknown. And the next question, what if the n is the unknown, right? And that's totally plausible. That's totally, conceivable situations. In other words, why? Because, it's not a difficult thing. It's, we all know, we are given, so if P is the 10K, principal is 10K, so you have 10K and you put it in the bank and you have a target future value, right? You have a target future value. You want to grow it to 30K. You want to grow it to you want to grow it to 30K, and your timeline is, I'm going to put it up there. Your timeline is 5 years, right? That means, you want to grow your 10K to 30K in 5 years, then obviously the question is, what should be the R, right? And the question is, what should be the R, right? So now let's think about it. How do we solve for this? Actually, you already know the answer. Why? You already know the formula. You remember back in our first topic, ROI, right? Back in our first topic, um, return on investment. Um, I gave you the formula for geometric average. I wonder if anybody remembers that. Yeah, exactly this file. Wonder how many of you. So it was basically about the reason I brought up the house value example was because it is a very good example to learn about the concept of the holding period return and the annualized return, right? Remember, in this example, you bought the house, right, for this price at the end of 2005 and sold it at this price at the end of 2016. So there has been, it's been 11 years, right? And over 11 years, capital gains was 350K. So for the 11-year holding period, for 11-year period, right? This formula is a little weird, but it won't be, but still the same thing. Basically, the concept of holding period return is PT plus N minus PT, right, over PT. So, and then this PT plus N minus PT is called capital gains. So here, and I could do it also simply by dividing the PT plus, dividing the capital gains, C14, which is capital gains, by PT, right? Still get the same result, right? But the case of scenario one, excuse me a second. And remember, there were two scenarios, scenario one and scenario two. And what was scenario one? Scenario one is the case where you buy the house and use it as your residence, basically, right? And scenario two is the case where you buy the house and use it as a rental property. You rent it out. Then the difference between scenario one and scenario two is, in scenario one, you have only the change in house value, right? The house value could, go up. Most likely, house value will go up unless the population isn't decreasing. So you will have capital gains or capital loss. But in scenario two, on top of the appreciation or depreciation in house value, right? In other words, therefore, capital gains. You also have additional income through the form of rental income, right? Rent payment, right? Rent payment. So holding period for 11 years under scenario 1 is 233%, but holding period return under scenario 2 is this, 347. But then we had to talk about the annualized return. Why? Because holding period can be different, right, across different investors and different investment instrument. In other words, some people, some investors, I mean, you can buy Amazon, you can buy Tesla. Someone may have bought Tesla in 2012 when it was, probably not even, $100, and held it for, 9 years, and then by now Tesla is 1,000. Look, Tesla was even $1,600 in early 2019, and then they all sold it, and massive sell-off because they wanted to take profit, and a lot of people who held it, who bought it, even when it was like $200. I mean, back in 2018, it was about $200, and then just over 1 year, it soared to like 1,600. So people, even people who bought that when it was 200, they realized what, like 8 times. They realized, like the gain, the gain of like $1,400, which is like 700% return, right? And those who bought it even at $400 made a very hefty return, right? 4 times, right? Or 300% return, net, right? Net return. And then after taking profit, it fell back to around 400, or if I remember correctly, 400 or 8. So then from 400, it crawled back up, and as of like second quarter this year, it was around $800. I bought 2 shares at the time, 2 shares, just because I knew Tesla was overpriced. So I just tried my luck with just 2 shares, Those 2 shares, I mean, I paid like 810 when it was 810. Now it is 1,100 something. At least I made, like $300, But look, my holding period was not even a year. My holding period is just about 3 quarters. Not even 3 quarters. Some people's holding period was 8 years. Some people's holding period was just some people who sold it in 2019, their holding period was simply could have been anywhere. I mean, everyone has different holding period. So then what's the problem with that? You can't compare, right? There's no way of fair comparison because everybody's holding period is different. the return over different holding period cannot be directly compared. Um, so that's the reason for uh, then, a simple answer to that is, why don't we take the average? Yeah, no, so how do we take the average? So in this case, the holding period was 11 years. So do we divide it by 11? No, no, that's absolutely not. And it's a very stupid idea because there's no meaning in it. You just divide it, just because holding period is 11, so you divide it by 11. Try dividing it by 11. And then it's going to be like 21%. But then, you can you say that is annual, uh, average annual return? No, no. Why? First of all, think about it. Another way to find the annual average would be, so let's find, okay, actual annual returns, actual annual returns. So um, capital gains for 1 year, right? Like in 2016 for 2000, it's between the end of 2015 and end of 2016, 86K, and uh, the base, the price base before that was this. So that's basically capital gains for 1 year uh, divided by PT, right? PT plus one minus PT divided by PT, right? So you do it for, and you drag it down. So for 11 years, you find the capital gains, and so uh, you find the growth rate or return, annual return. This is scenario one. Under scenario one, right, and drag it down. You have 11 11 rate years, annual returns over 11 years, year by year. So then, by the definition of average, why don't we then simple average, right? Why don't we what is C15? C15 is, yeah, that is no, this is wrong. Um, you can take, simply you can use the average command, or uh, let's just do this. Oh, yeah, no, no. You can do one of the two things, right? You can sum everything, because those are annual returns, and divide it by, or there are 11 data points, right? So that's 11 years, but just to make sure, how many data points are there? Will be 11. We come to this, right? And see, first of all, it's not very reliable. Arithmetic average, I did it here too. Arithmetic average, I did it here too. Uh, but it's not very reliable. I can, why? What about this? I mean, what is this? This is what we did, simply dividing it by 11 years. Also, I can, just to make sure, 11 years. Uh, uh, actually, you should, you should do like this, because not including this, because this is starting from the end of this year, right? So 2005 is not included. 2005 is not included because um, starting from end of 2005 through end of 2016 is the same thing as beginning from the beginning of 2006 through the end of 2016. So you include only from here to here. Now, when I did that, simply dividing this by 11 years, this was the result. And then if I average all of this annual growth rates, and because it's the same number, I mean, same thing I did here. Let me do it by average command. Average. Will give you the same thing, right? Will give you the same thing. So then, obviously, this is clearly not reliable, right? This is clearly not reliable. And is this reliable then? No, it's not. I told you it's not reliable. Why? I mean, it's not exact. Why? Because there is a compounding effect, and it has ignored. I mean, simple average ignores the compounding effect, right? And I told you everything that has time dimension, everything that grows over time has the compounding effect, right? The time aspect to it. It's got time aspect to it, the compounding effect. So therefore, then what is the correct way to find the annual average? In other words, annualized. Average of the annual growth rates must be through the geometric average. And at the time, I already gave you the, if you remember, I gave you already the formula, but because it wasn't yet, you were not ready for it yet, I didn't go about how that formula was derived, right? So at the time, I just threw the formula at you. It's basically, okay, or in this case, and at the time, it is the same thing as just growth rate. R equals FV over P raised to 1 over N minus 1. Okay, and then two questions. And I already did this two questions, R and G, how they are different. But obviously they are the same thing here because of this equal sign. They cannot be the two different things. They must, and the two questions that arise are, one, how did we arrive at this? This is an end result, right? End result, final product, right? So how did mathematicians, how did the mathematicians arrive at that end result? Or it doesn't have to be a mathematician, economists actually. And why is it like this? Why, right? Okay, it's important to answer these questions rather than just memorizing the form, memorizing it cold, right? You can memorize it cold, but that's literally cold. As time goes by, after this semester, you will forget, right? But if you understand how, right, then you will hardly forget. If you know how to derive it yourself, you will hardly forget. First of all, the difference between R and G, actually, they are the same thing. They are only different. Look, So here, in this, a house value example, the column E is G, growth rate. Column F is rate of return. Well, they are different, right? But up to a certain point, they are the same, right? Look. The first 3 years, they are the same. Of course, the first three years, they are the same because why? In the first 3 years, there was no, why isn't, I'll just, in the first 3 years, there was no rent. There was no rent that came in the first 3 years. So then the difference between scenario 1 and scenario 2 is the rent. So think about it. In scenario 1, the source of return is only capital gains, right? But in scenario 2, the source of the return is both capital gains and additional income. And therefore, for the first 3 years, they must be the same, right? It must be the same. So growth rate is the return in scenario 1, right? And the rate of return is the return in scenario 2. So in other words, if there is no, and think about it, therefore, what additional income is there in this scenario, right? You put 10,000 in the bank, and it earns interest compounded over and over. So basically, it's like a growth in your house value. It's just like the growth in your house value, right? It's like you bought the house for $10,000, and over time, it grows to 30K in 5 years. So it's capital gains, basically, right? The interest income is adding to capital gains, and there's no additional income. Therefore, it's just like scenario 1. Therefore, the return is the growth rate, right? Next question is, how is this arrived at? How is this end result arrived at? Okay, so to answer that question, first we got to start with, first, of course, as I said, always, we need to start with the initial equation, and the initial equation is always this: p times 1 plus r raised to n. It's so raised to 1 plus r raised to n. Now, the thing is, our biggest problem is that we need to solve for r, but to solve for r, we should be able to isolate r. But there's no way we can isolate r immediately, right? Why? Because it's inside this parenthesis. It's inside the parenthesis, and on top of all that, So it's like in a cage, and then there is a padlock on the cage, right? So you must first unlock this padlock. You must unlock the cage, right? You must unlock the cage. But you cannot do it. To do that, um, you must first isolate this cage, right? You must isolate this cage alone. So how do you do that? Well, of course, you will have to do whatever you can. First, isolate the cage. Then you will have to divide both sides by p, right? And then the cage is now isolated. Then next, you must unlock this. This is a padlock. You must unlock it, right? You must remove the padlock. But then how do you do that? Hmm? This is like previously, this was like a z equals x times y structure, right? Z equals x times y format. Now it is like, so we isolated only y. Now it's more like, now it is like z equals x raised to y format, right? It's like z equals x raised to y format. Then how do we unlock, unlock y and free x? Well, here's the thing. This is why we have to, this is why, math foundation is very important. We need to review some properties of power, or properties of exponent. So everyone knows that x squared, right, can be turned into x by taking the square root. Okay, so if x squared is y, right, if I cannot draw, let me, if I can I copy this? Let's see if I can copy. No, no, I'll just do it. So here, so it's like z equals x to y, and just like that, think about it. So if y equals x squared, if y equals x squared, then if we take the square root of x, square root of x squared, not square root of. If we take the square root of x, and you think, you can write square root. This is just one way. Generally, they ignore when it is square root. This means root. This the root sign. That's not only for square root. It can be, there are, not only square roots, but the third root, fourth root, fifth root, any, nth root, right? And to distinguish square root from, cubic root or fourth root, it is originally, right? This 2 is required there. And then taking the square root, it is the same thing as, another way of writing it is, suddenly, another way of writing it is x squared raised to 1 over x. Okay? Now, you may, back to the basic properties of power. First of all, everyone understands that anything raised to 0 is 1. And I'm gonna give you an example later. Anything raised to 1, 0 exponent property. Anything raised to 1 is 1. Anything raised to 0 is 1. And the negative exponent, you should know, it's a reciprocal, right? A raised to negative b is 1 over a to the b. For example, x to the negative 2 is 1 over x squared. And just like that, x to the negative 1 x to the negative 1 is simply 1 over x. Okay? That's the reciprocal, right? Negative exponent. And then product of powers, right? So same base, a raised to b times a raised to c is simply a raised to b plus c. Okay, which is, now do a little, just do a little, you can do a little thought experiment and you will see. So for example, now think about it. This is very hard. If you have 2 squared times 2 cubed, what is that? We already know 2 squared and 2 cubed. This is, 4, and this is 8, so 32. But then think about it. If we do it like, 2 raised to 2 plus 3, which is 2 to the 5th, right? What is 2 to the 5th? Again, that's 32, right? 2 times 2 times 2 times 2 times 2, right? 32, right? So that's the, and then stay focused. Don't lose focus. People, just these days they say, the attention span of average attention span of people, younger generations, is no more than 30 seconds. But the more you can focus, the more you can concentrate, the better you will be. I mean, the more the smarter you will become. Now, and the power of power property. This is this property, power of power. A raised to b And that thing raised to c is a raised to b times c. And a simple example, let's do a simple example. So let's try this. 2 squared cubed. And what is that? You will say, it's 4 to the third, 4 to raise the third power. So it's 4 times 4 times 4, so 64. But then think about it. Isn't that the same thing? If you can do it also like 2 to the sixth. When you multiply these two, 2 to the sixth. Anyway, 2 times 2, that's 64, right? So, in other words, we are using this rule, right? Think about it then. Square root of x squared is like x squared raised to half power, right? That's basically how you do square root, how you express. That's another way of. Then that's the same thing as x raised to second power times 1 over 2. They cancel out. So it just becomes x to the 1, x, right, itself. That's why when you take the square root of x squared, then it becomes x, right? But then when you do that to the right-hand side, think about it. If you do something to the right-hand side of the equation, you have to do the same to the left-hand side of the equation. That means the left-hand side of the equation should also be the square root, right? Right? You do whatever you do to the right-hand side, you do the same thing to the left-hand side, right? That's the right thing to do. And then, therefore, eventually, then it becomes you can write it like this. You arrive at x you came to x, right? Because you took the square root of x squared. And at the same time, you should also take the square root of the other side of the equation, right? Then think about it. Now, that answers everything. That answers our question. If that's what you do, then think about it. We want to open up this. We want to open up this n, right? The exponent. And what do you need to do? Then what you will need to do is you will need to take the nth root, nth radical, nth root of the right-hand side, and you need to do the same thing to the left-hand side, right? You'll need to do the same thing to the left-hand side. And then we all know this this n and n will cancel out. So it just, it loses the cage because cage is now open, right? the padlock is gone, the cage is open, but in the right-hand side, it will still be, right? That's the thing in the bracket. Because I don't want to write it over and over. Then, rearranging everything. Now, think about it. We are only, we want to know what R is, right? So we can isolate only R because, this cage is now gone, right? This 1 plus R here, right? And it's the thing in the bracket raised to 1 over n. And we want to isolate R. So then you must subtract 1 from both sides. If you subtract 1 from both sides, then this side will become R, and this side will become FV over P 1 over n minus 1. Okay? Now think about it. This is exactly the formula I gave you. Isn't that right? This is exactly the same formula I gave you. So we finally arrived. So we finally arrive at this formula, which is basically the formula I gave you, right? So okay, that's exactly that, right? Everyone is okay with that? Hmm? Okay. Any questions? Any questions so far? Is everyone there? Angelica, are you there, Angelica?
I'm here.
Okay. Are you good with that? Are you good with?
Yes. Yeah.
Okay, great.
Professor,
Okay.
I was wondering really quick. So for our midterm, it says like we're going to get the score another day, and I was wondering when are we going to know what grade we got?
There is basically 24-hour hold period for the result
Mm-hmm.
to prevent any cheating or collusion, because some people finish early, they get their result, and some people haven't started yet. Um, so some people collude, with each other. Uh, to prevent that, I put 24-hour hold period. So 24-hour is over now already, because it was due Sunday night, right? 11:59 p.m. So as of midnight yesterday, or 0 hour today, that 24-hour hold is over,
Okay,
right?
so it should be
You
on
can
Connect our grade, right?
Yeah, you should be able to review your exam.
Okay, thank you.
Okay. All righty. Now, Brandon, are you there, Brandon? Brandon?
Yes, hello, hello.
Yeah, Brandon, good to hear from you. So you understand, you follow everything? You follow? Hmm?
Yeah, I understand the background of it is pretty helpful.
Okay, great. So, yeah, just one. Jeremiah, are you there, Jeremiah?
Yes,
Jeremiah,
yes,
any questions so far? Any
no,
questions?
no.
No? Okay, good. Carolis, are you there, Carolis?
Yes, hi.
Okay. Hi. Any questions so far? Any questions?
No, not at the moment.
Okay, great, great. Maricel, are you there, Maricel? Maricel, I would have to assume Maricel is away. Naomi, are you there, Naomi?
Yeah, I'm here.
Okay, good. Any questions so far? Any questions?
No, I'm good.
Okay, good, good. Uh, Nicole, are you there, Nicole?
Yeah, I'm
Nicole?
here. Hi, Professor.
Okay, good to hear from you. So any questions, any concerns, any inputs?
No, I think I understand so far.
Great, great, good. Nikri, are you there, Nikri? Nikri, I'll have to assume Nikri is away. Noel, are you there, Noel?
Yeah, I'm here.
Okay, everything good so far?
Yeah.
Any questions?
No, I don't have any.
Okay, alrighty, Vivian, are you there, Vivian?
Yes, hi, Professor.
Hi. Any questions? Any concerns? Any feedback?
No, no questions.
All righty, good, good. All right, so I think this is a good time to take a 10-minute break. It's 11:59, so we'll take a 10-minute break and we'll reconvene at 12:10. And when we come back, we're gonna go over the Excel uh, example of this, this formula. Okay. All righty. So let's take a 10-minute. All right, we're back. We're back. So, so let's go to our Excel file. Let's go to this file, right? You downloaded this file last time, so you should have it. So please open it in front of you, okay? Make sure you have this in front of you. And if you have it in front of you, go to row A10, and delete all the highlighted cells, okay? Also, in the box below it, in the box starting at row 24, right? Delete all the highlighted cells, okay? Delete all the highlighted cells, okay? You must delete all the highlighted cells. Delete all the highlighted cells, okay? So, does everyone have this file in front of you? Does everyone?
Yes.
Okay, great. So now let's get started. So this is our original question, right? The question I posed at the beginning of this class, beginning of this session. The question was, if you have $10,000, right? You have 10K, and you want to grow it to 30K in 5 years. You want to grow this 10K to 30K in 5 years. Then what should be the rate, right? What should be the interest rate? So 10K is your principal. You have a target future value of 30K, and your timeline is 5 years, right? And what should be the annual, right? APR, what should be the annual? Because all the rates must be basically, annual, right? APR. Let's go to this example. That's exactly that example, isn't that right? Your principal is 10K. Your timeline is 5 years. Your target future value is 30K. Then what should be your APR? And of course, we can also consider a situation where compounding is not just annual, but quarterly, right? We can think about the situation where compounding frequency is different, or higher than just once a year, right? But first, let's think about the easiest one. And we know already, we have the formula. The formula is what? FV over PV, right? These two. 1 over N, and it's 5 years, and that 5 is in C18. And I would like to click it in, but then since this formula is hanging over, right? It's overlapping, also column C, and then you can't click it in. Then you will just need to manually type it in, C18, and then -1. Okay, and then it should give me exactly. Yeah, in that case, it's going to give me 24.57%, right? It's going to give me 24.57. Yeah, just think about it. It should take something like this 25% interest rate. It should take something as high as that to triple your money in just 5 years. Okay? And our next example then is, if compounding is quarterly. So it would make it a little more complicated. So let's break it down. So it would be, the formula would be less complicated. Okay, so here I did it in row 25. So as you can see, it's the same scenario, right? Your principal is 10K. Your future value is, target future value 30K. And in time, 5 years, compounding frequency 4, quarterly. Here, I added 2 extra columns, and these columns are for periodic rate, and then for n, the actual number of compounding. So in other words, we want to find the periodic rate first, because the formula is for periodic rate actually. And if the compounding frequency is 1 annual, then annual rate is the periodic rate, right? Annual rate is the periodic rate. So here, first, I will need to figure out how many compoundings actually happen over 5 years. And we know there's going to be 20 compoundings, right? And then let's use the formula for R, FV over PV, present value, raised to 1 over N, and the N is in, I cannot click it in, so I will just type it in. N is in F25, right? And minus 1. There you go. So this is the quarterly rate. Right? Every quarter, 5.65% will be applied. And then eventually you will need to give the answer in annual rate. So then annual rate will be simply, think about it, quarterly rate times, will have to be quarterly rate times 4, right? There you go. And then it is 22.59%. You might wonder, oh, why? How come? It's different from previously it was 24.57. Why is it different? Of course, it will have to be different because previously it was compounding was annual. Now compounding is quarterly, right? And remember from basically in it's only mathematically, it will have to be mathematically true that the higher the compounding frequency, right? In other words, the more compounding per year, the higher the compounding frequency, the greater the future value. So then, if I had the same 25 APR and compounded quarterly, the future value cannot be 30K. It will be greater than 30K, right? I mean, given the same interest rate, same input, all the same input, same interest rate, same present value, same future value. Given the same input, same principal, same interest rate, same time, and then if the only difference is the compounding frequency, and if the higher the compounding frequency, right, then the future value will have to be greater, right? That means if the future value is the same, right? Because we have it's the target future value. 30K is the target future value. If this was already given, then the only way you arrive at with quarterly compounding, the only way you can arrive at the same future value is by lower APR, right? And if you use, so that means with higher compounding, right? With more compounding, the money works harder, right? With higher compounding, the money works harder, and so it won't need to take more. It won't need to take uh, as much interest rate as before. With lower interest rate, you can still arrive at the same result, right? And to put it in another way, if you use the same interest rate, then the future value will be greater when the compounding frequency is higher, right? But let's try this again here. Let's do this here. If I do it there, first, I will, of course, FV over P. Then I'll raise it to 1 over N. Well, I know N is this time, N is C20 times E20, right? Close parenthesis. And don't forget, and then minus 1, don't forget, the reason I put the parenthesis here is so that the Excel will know that C20 times D20 is one chunk, right? One number, right? If you don't do that, Excel will only, because it is linear, right? To human, if I write it, on the paper, well, human eyes can tell. C20 times D20 is one chunk, right? But if written this way, it's linear, and Excel won't be able to tell that without the parenthesis. Without the parenthesis, then what's going to happen? It's going to do 1 divided by C20 first, and then the result will be multiplied by D20, and then it's going to be a completely different result. So you should be careful. It's always PEMDAS, right? It's always PEMDAS. So if you do that, what do you expect? What do you think you're going to get? You're going to get exactly the periodic rate. Yeah, that's right. That's what the formula is supposed to give. But then it's not the APR, right? It's not the APR. What you have to answer eventually is APR. Then what do you need to do? You will need to put the whole thing in the parenthesis and multiply it by the number of the compounding frequency, which is in D20, right? Which is 4, right? And then you will get exactly 22.59. Okay? But then think about it. This one is quite complicated. This one is quite complicated. And the more complex the formula, the more difficult to detect if there's anything, if there's any error, if something goes wrong, if anything goes wrong, it's hard to identify the source of the problem, right? It's hard to identify the source of the error, and it's going to be more difficult to fix even if you discover the source of the error. So that's why you don't need to make it more complicated. Rather, you will simply break it up into just by adding 2 more columns for periodic rate and the column for actual number of compounding. And everything boils down to very simple basic structure, right? So in other words, you make adjustment outside the formula, right? So it can be, the formula can be simpler. And in the formula will be then exactly very simple, very basic formula. And then all you need to do is, finally, you make adjustment, right? You'll need to make adjustment. All right. So then our next question is finally, some people might say, so why go through all that? Why can't we use just Excel's built-in function? Yeah, you can use Excel's built-in function, but once again, to use it correctly, right? You should think. Without thinking, you cannot use it correctly, because it's the rate function we need to use, and then so rate, and this opens up n periods. What are you going to do? You're going to enter, most people will just simply, enter 5, because that seems like n. But then, it is wrong. And there is no payment. Present value, you must enter this as negative. Still, in other words, your mind should stay sharp. Your mind should remain sharp through all this process. If your mind is not sharp, then you are prone to make a mistake. And doing it this way, you're, already, making a mistake. Because if you do that, you get this, right? But then that's wrong. Why? Because when you did, n periods, right? You should, if your mind is still, staying sharp, if your mind is sharp, if your mind remained sharp, you would realize, oh, actually, it should be 20 periods, right? So multiply that by d20, and then you get it. And then what you get is then that's the periodic rate, not the annual rate. So then what do you need to do? Eventually, you will still need to make adjustment like that. Put the whole thing in the parentheses and times 4. Okay, then you get it right. Again, then this means, just using Excel's built-in function that alone cannot correctly answer the problem, correctly solve the problem. Everywhere it requires your conscious design, right? Everywhere, at every step, requires your conscious design, right? And as long as you have to use your conscious design, why not do it this way, right? Rather than, why do it this way? I mean, it's not simple, it's not easier, right? Just by using Excel's built-in function. And if you do it this way, by conscious design, you made it simpler, right? So that's the reason why you have to use, a structural model, or, the model that explains the mechanism behind it, not, just the black box, right? Where you just punch in the data. If you just punch in the data, you will never get it right. Now, next. So our next question is then, as I said, there can be so we have answered, 3 questions, 3 unknowns. We have solved, we have answered the questions for 3 unknowns. Finally, the last unknown, n. What if the n is the unknown, right? What if the n is the unknown? Yeah, that's the quite plausible scenario. So again, it is perfectly, plausible that you don't, when everything else is known, what is that? A hexagonal. You have the principle of 10K. This is very difficult. You have the known interest rate of 10%, and you have the target future value of 30K. Then the question is obvious. Then how many years will it take? Question is, so what is the problem? Right? How many years will it take? So we need to solve this equation for n. Then let's start with the mother of all equations, mother of all time value equations, Basically, we know the starting point is always FV equals P times 1 plus R to the n. And this time, everything else is known. It's known, but this is the unknown. So how do we isolate n? How do we isolate n? That's a big question, because first we will need to isolate whatever we can. So first you will divide both sides by p. So in the right hand side, you will have 1 plus r to the n left. And again, now we come to an impasse. We come to an impasse, dead end. Is it really a dead end? But look, again, now this is a z equals x times x raised to y structure, x raised to y structure. Previously, we were able to isolate x and open up x to solve for something inside x, right? But this time, the exponent is the question. When the exponent is the question, how do you solve for that? Now, the only way you can solve for it is by utilizing the properties of logarithm, or log. So first, let's review what log is. So log is basically a way of expressing a large number by the exponent of a base. So basically, we know very often we know what common log is. There are three types of logs: common log and the binary log and natural log. And let me use common log for example. Common log is where so we all know, basically we all know that we all know 100 is 10 squared, okay? And 1000 is 10 cubed, also, 10,000 is 10 to the fourth, right? 1 million, right? Ah, 10 to the sixth. And then 1 billion. Yeah. 1 billion is 10 to the ninth. And then 1 trillion and look at all those commas, number of every 3 digits you have comma. So when you see 4 digits, that's already when you see 4 commas, that's already 12 zeros, right? 10 to the 12th, 1 trillion. Beyond 1 trillion, beyond trillion, there's quintillion. Quintillion means five commas, right? 5 commas, right? Or 15 zeros, right? I don't even know after what's after quintillion. Maybe hexillion with 6 commas. But then think about it. All of these numbers can be easily. These are lots of zeros. So is there a better way? Yeah, we can. Instead of all those zeros, 10 to the 12th, 10 to the ninth. But then we can also write it as base 10 log of 100, or so what we can do is base 10 log of 100, right? And which is then base 10 using 10 as the base, right? 100 is base 10 log of 10 squared, and this is a very nice properties of log. When the base and this base is the same, right? And what you can do is you can bring this down, right? You can bring the exponent down, so then it becomes what? You can write it as 2 times base 10 log of 10. Okay? And then think about it. Base 10 log of 10, that's basically 1. This thing is basically 1, right? Think about it. Base 10 log of 10 means, what this means is, log 10 of 10, base 10 log of 10, which means 1, right? Right? The 10 itself, so 10 to 1 itself, right? So the whole thing simply then, because this is 1, the whole thing simply collapses to 2, right? 2 times 1. In other words, all these large numbers are simply expressed as their exponent, right? Exponent. to the base, right? So that means, through the same process, right? So through the same process, then you can say, you can do the same thing, right? You can do the same thing. This will be log, base 10 log of 10 cubed, which will simply be 3, right? Oops, what happened? And then this will be base 10 log of 10 to the 4th power and 4. And, you get the idea. This will be, 6. Now, then why do we bother to do this? I mean, other than saving the lots of zeros when writing, other than lots of zeros, I mean, is there any, we can bypass or we can get around, writing a lot of lots of zeros. I mean, even simply by the, power, we can bypass, right? We can get around a lot of zeros. Why do we have to even use log? Now, suppose, think about it. This is a very cool thing, if you think about it. Suppose you are, you have you're like Jeff Bezos or Elon Musk, multi-billionaire, interested in space rather than the welfare of their employees, right? So you want to be the first guy to send a rocket to the nearest galaxy. And the nearest galaxy to the Earth is Andromeda Galaxy. Andromeda Galaxy is like, tens of, hundreds of light years away, I believe, hundreds of light years. At least, that's the nearest galaxy to our galaxy. And then, how do you then express the distance between graphically? How would you express? For example, if you draw a line, the space is limited, right? I mean, the drawing space is limited. So we will use, some scale. Of course, this will be like, 1 to the billionth of a, scale. But then, let's say this is the distance between Earth and the sun. Okay? So here's our sun. And let's say this is our Earth. And this is the distance between, the Earth and the sun. And let's say the distance between the Earth and the sun is, let's say, 10 billion miles, but let's just say 10, just to make it simple. And then the nearest galaxy, Andromeda Galaxy, will be like, that would be like 15th notch from, 1, 2, 3, right? Okay, so it looks like, it's only 15 times between the, 15 times the distance between the sun and the Earth. Is that what you're saying? No, obviously it's way more than 15 times. But why do you say it just means 15 times? Because you know no more than just normal scale. You don't know log scale, right? In normal scale, if this is normal scale, ordinary scale, normal scale, then it means 15 times. But then in logarithmic scale, 15 means, 10 to the 15th power. If this is 10, so this is 100 times, right? This is 1,000 times. 3 is not 3 times, 1,000 times. 4, 5, 6. 6 is million times, right? Think about it. And then 9 is trillion times. 10 to the ninth. 12 billion times. 9 is billion. 12, that's trillion times. 15 is like quintillion times. I mean, 15 should be somewhere here, right? So what it means is, if we use logarithmic scale, we can condense huge number, right? We can condense huge number into more manageable scale. So that's why we use log. That's just one reason. But think about it. I mean, this is how it can. Now it's already we're already 7 minutes past the hour, the time we have to finish. So our time is up. I'll need to class is dismissed. And before we close, any questions? Any questions so far? Any questions? No questions? All righty. So then, have a great afternoon, and I will see you guys on Thursday. Okay?
Thank you.
All
Have
right,
a
have a
good
good one.
All right, you too, Angelica and Brandon. All righty. Class is dismissed. I'm gonna stop sharing and stop recording and sign out.